Everybody, we're going to be learning today about slopes, equations, and graphs of lines. Stuff that looks like this for slope. Maybe we'll find an equation and graph it like this, or two different ones and see the intersection, or graph a line like this with 2 points. I bet you've all done stuff like this before, and we're going to do it over again. And if you didn't learn it before, you'll learn it now. And if you know it already, then this should be pretty easy for you. So let's start out with the famous y equals mx plus b. We've seen this. This is the slope-intercept form. It's the most famous we always use. Y equals mx plus b. The m stands for what? The m stands for the slope. And the b stands for the y-intercept. You guys have seen this many times. If you know this, you'll be fine. All right, well, let's start off with the slopes of lines, which is usually starting with the m. So we know that the m equals actually the rise over the run. It's going up before it goes across. And that's going to also equal what we like to say the change in y over the change in x. And that actually also equals y minus 1 minus y2 and x1 minus x2. And we're getting these y's and x's from 2 different points. So if we have 2 points, we can find the slope. Take a look at lines A, D, and B. Can you find the slope of each one? Go ahead. Okay, now I can show you how to find these slopes. So I'm starting out with A in the equation. So then we look at what's my y's, and then I put that over the x's. And I do my math, and we get 2 over negative 2, which is negative 1. Now let's look at B, the green line. So I'm going to go right for the y's over the x's, and I get 4 over 2, which is 2. Now let's do the red line. D equals, to start with the y's over the x's. All right, we do my math. We get 4 over 0. That's undefined. You can't have that. You can't have a 0 in the denominator. All right, let's look at the last one, this other green one, C. All right, looks like 4 minus 4, 0 on the top. Oh, that's okay. Now let's look a little bit more at slopes. Let's take a look at this slope. If it's positive, that means that the slope is going to be positive direction. It's going to look just like this. It's going right to left, it's going straight up. If we actually are negative, then the slopes are going to be a little bit different. The slopes are going to be up like this, and a negative slope looks like this. This is a negative slope when we're coming down like that, like downhill. If we're talking about a slope that has no slope, then a slope is going to look something like this. We have no slope here. It's just flat. If we're also going to talk about something that is an undefined slope, then we're going to have a slope that looks like this. These are all different types of slopes. All right. Now we're talking about parallel lines. There's something that's going on with the slopes. The slopes have always the same. We have the same slope. Which lines do you think are actually have the same slope? Take a look at here for the parallel lines. We're going to have the same slope. Parallel lines. So let's take a look at K1. Well, let's start out with the y's over the x's again. We're going to find out that the slope is actually 4 over 1. Cool. Let's look at the second line, K2. We find out again that the slope is also 4 over 1. Interesting. That means they have the same slope, so they're parallel. All right, let's look at the last line, K3. All right, we do the y's over the x's to find the slope. But look, we end up having 5 over 1. And that's not the same. So it is not a parallel line to the other lines. So the green line is not the same. It is not parallel to the other lines. Perpendicular lines, all right, these slopes are going to be opposite reciprocals. Well, what's an opposite reciprocal? Let's take a look at an opposite reciprocal. Here are some examples of opposite reciprocals. We can have a over b, and that turns into negative b over a. Let's take a look at some other ones. If I had negative a over b, then that turns into what? Positive b over a. Keep on looking at some more examples. If I have 3 over 2, what does that turn into? Negative 2/3. Okay, another opposite reciprocal, negative 4/5, that turns into 5/4. What about 2? Oh, negative 1/2. Okay, now let's look at this graph here and let's see if actually these two lines, line H and with the blue line and the red line, if they are actually perpendicular. To see if they're perpendicular, we have to see if the slopes are opposite reciprocals. So we start with the red line. And let's find the slope of the red line. So I'm going to start with the y's over the x's for the slope. The x's are 2 minus 5. And that's going to equal 2 over negative 3. So that's the slope of the red line. Let's do the slope of this blue line. We're going to have y's are going to be 6 minus 0 over 7 minus 3, which equals 6 over 4. All right, which equals actually 2/3. And that's actually opposite reciprocals. Yes, they are perpendicular. All right, why don't you go ahead and find the slope of this line, and then I'll do it for you. So pause the video and find the slope of this one. Go ahead and find the whole equation to this line. We're going to do y equals mx plus b. Let's find the m first. All right, so using the 2 points, we're going to find the slope. Y's over the x's, and we end up getting 6 over negative 3, which is really negative 2. So we have m now. And I can say y equals negative 2x plus b. We still need to find the b. So we're going to take 1 point and put it in for the y, another point put in for the x. And once I rewrite this with the x's and y's in, I'm going to get the b left over. And I end up getting that b equals 4. And then I can rewrite everything. I have the m and the b. Y equals negative 2x plus b, or plus 4, is the final equation. Okay, I want you to write an equation of a line passing through the point negative 1, 1 that is parallel to the line with the equation y equals 2x minus 3. So go ahead and I'll actually show you how to do it. First, we got to find out that this line is parallel. So it's going to have the same slope as that line. So we're going to have it y equals mx plus b. I need to find the slope. Oh, it's 2 because it's the same. Parallel the same. I need to use this point now. Plug it in the y and the x. And I'll plug it in and I get y is going to be 1 and x will be negative 1. And I have b left over. Now I can easily find b. B is 3. And then I can have everything, the slope and b, y equals 2x plus 3. There's my equation. Now I want you to write an equation of the line j passing through the point 2, 3 that is perpendicular to the line k with the equation y equals negative 2x plus 2. So why don't you try it first and then I'll show it for you. We're going to find the equation of perpendicular, then we need the opposite reciprocal of the slope of the other line. So the opposite reciprocal, we have y equals negative 2x plus 2. The slope is negative 2. What's the opposite reciprocal of negative 2? It's 1/2. Okay, so we have y equals 1/2 x plus b. We know that it's going to be 1/2, but we're going to use this point, plug in 3 for y and 2 for x. Then we can solve for b. So plug it in, and then we're going to have b left over. We solve for b. We get b equals 2. And then I have b, I have my slope, and I can plug it into y equals mx plus b. 1/2 and then 2. y equals 1/2 x plus 2 is the perpendicular line to the other line. All right, if this is standard form, we usually want to find the x-intercepts and the y-intercepts. So why don't you try and graph this on your own and then watch me do it after. So pause the video. So to graph this equation in standard form, which is 3x plus 4y equals 12, we're going to find two things. We'll start with the y-intercept. The y-intercept, we put in 0 for x. So we'll have 3 times 0 plus 4y equals 12. We end up getting y equals 3. Next, we find the x-intercept. With the x-intercept, we make y 0. So we'll make y 0 here. And we get x ends up being 4. So we have 3 and 4. But notice, look at the graph. Where does the graph cross the y-axis? At 3. Where does it cross the x-axis? At 4. All right. I'm going to graph these two lines up here. And then I want you to try and graph these two lines down here. All right. Give it a go. Okay, for the top two, it's very easy. Y equals 4. We count out 4. Y is always 4 there. For x, we're going to go count over, and x always equals x there. Now, if you can understand what the top two look like, try and do the bottom two. Okay, now I'll show you how to do it. You're going to, for y equals -3, it's going to look like that. For x equals 5, it's going to look like that. Horizontal and vertical lines. All right, now what I want you to do, I want you to actually write an equation for each one of these lines. Pause the video and find the answers. I'll give you the answers afterwards. So in super speed mode, these are all the answers. I'm only going to give you the answers here, and you can ask me for help or someone else help if you got the wrong answer, and figure out how to get the right answer. How do you write equations for each one of these lines? I now want you to find the equation to all of these lines. I'll give you the answers after. All right, so now I'm going to give you the answers real quick for just 10, 13, 16, and 19. All right, now why don't you do just number 24, and why don't you also do 31? These are good questions. Give them a try. Now here's the answer. And here's the other answer. Okay, cool. And that is it. Thank you very much. You can work in your practice workbook when you're all done. Thanks.